Hello friends, welcome to your own channel on artificial intelligence and machine learning. You are watching this playlist on SQL programming. I have uploaded many other videos on Python, R, data science and machine learning algorithms. If you like my effort and you have come to this channel for the first time, I request you to subscribe to my channel. Thank you. This will motivate me. Okay, let's get started. In our last video, we said that we are going to start with basics of database. So in this video, we are going to learn basic concepts of database. What is database? What is the objective, asset properties, and so forth. It would be theory. I know you want to jump into writing SQL syntaxes. Don't be so eager. Try to understand the concepts. Concepts are more important than the syntaxes. What is a database? Technically speaking, without getting into any software, database simply means an organized collection of information. If you note down all transactions properly, details of all your customers properly, using pen and paper, even that becomes a database. Only thing is, it is more tedious and it requires lots of effort. So we require some software to store data in a nice organized format. We can use even Excel to store and collect data. However, as the complexity goes up, we require much more organized and much more scalable solution, and that's where we require a database system. So you need to understand that there is a difference between what is a database. It is an organized collection of data, organized collection of information. A simple telephone directory is also a database. To be able to store the data in a systematic format, which enables you to quickly retrieve and manage the data, that kind of a system is a database system. Now there are many commercial and open source database softwares which are available. Two open source databases which are very prominently used in industry is MySQL and PostgreSQL. They are very popular. There are many other proprietary commercial databases: MS SQL, Microsoft SQL, Oracle, Teradata, and so forth. For our training purpose, we have decided that we will take MySQL. In the previous video, I have explained the steps to install MySQL. If you have not seen that video, see the previous video. Okay. Now, a database system has an architecture of storing data. There are two important things in a database. One is a schema, and second is the data itself. What is a schema? The structure, the format in which you store data is called schema. For example, I have customer, I have account, and I have transaction. A customer comes in, gives his or her basic demographic details, and I store that information in a table called customer. This customer takes from me a product or a service. For that product or service, I open an account, and what kind of product or service the customer has taken, you can, for simplicity, think of account as a banking account. You have taken a savings account from the bank, checking account or a current account, and you save that account. And as a customer, you start doing transaction, for which you create a table. for which you create a table. Sorry. You create a transaction table. Now, what all fields you capture in the table? For customer, you may capture name, gender, date of birth, occupation. For accounts, you may have certain fields, and for transactions, you may have certain fields. This structure is called the schema. So a schema defines the tables, the columns in the table, the data types of the column, all of these together, and how the table is linked with one table is linked with another table. All of that is part of the structure, and we call that structure as one word, schema. The actual data which is stored in this tables is the data. So a database has two components. One is the schema, second is the data. To create the schema, you require create syntax. That is part of data definition because you are defining the structure. So we have certain types of syntaxes by which we can create, alter, or I don't want a particular table, then drop. These kind of syntaxes which impact the schema, they are part of your data definition. The syntaxes by which you insert, update, delete, select data, they are part of your data manipulation. Who can access data and who does not have the privilege, or someone had privilege and you revoke the privilege, these syntaxes are data control language. So broadly speaking, once we get into SQL syntaxes, there are three types of syntaxes you should be aware of. Data definition, which has create, alter, drop. Data manipulation syntaxes, select, insert, update, delete. And data control language, grant or revoke privileges. So these are part of the SQL syntaxes. All the database system follow ANSI standards to a large extent. ANSI standards is American National Standards Institute, who first created the standards for SQL syntaxes. The beauty of this standard is whether you work on a MySQL database, which is open source, or whether you work on Microsoft SQL database, the structure of SQL query remains same. Most of the standard SQL syntaxes will work as it is in MySQL or Microsoft SQL. What does this mean for you? For you, it means that whether I learned SQL using MySQL or whether I learned SQL using Microsoft SQL, it does not matter. If you know SQL with one database, you know SQL with any database, because most of the syntaxes will work as it is. Only difference would be in the functions. One system may probably say average as AVG. The other database may probably call average function as the full spelling. This is where you need to only tweak your SQL syntaxes. I'm just giving this as an example. Don't assume that there is only this difference. What I'm trying to say, the name of certain functions may differ from one database to another. Broadly, the outline of the syntax remain same. Okay. all the databases have to follow the ACID properties. What is ACID properties? A stands for atomicity, C stands for concurrency, I for isolation, D for durability. At a high level, we will try to understand these ACID properties. Database will maintain all of that in the background. We don't have to bother about it. Atomicity ensures that all of the steps involved in a transaction complete successfully as a group. If any step fails, no other step should be completed. In simple words, you are writing some SQL query and you are writing the SQL query in a stored procedure between begin and end. You have written SQL query 1, SQL query 2, SQL query 3, SQL query 4. When you execute it, the first query executed successfully, second executed successfully, third failed. Now, because this is a group, what this atomicity says, you executed these set of SQL syntaxes as a group, which means either all of them should be successful or none of them. Because it failed at step 3, whatever changes you did in step 1 and step 2 will be rolled back. They should not be committed. They should not be successful. That is the meaning of atomicity. Second is concurrency. What it means is two users cannot change the same data at one given point of time. Let's take simple example. Balance in my account, in an account table, balance in my account is say 5,000 rupees. I try to do two transactions almost simultaneously, one through mobile banking and another through net banking, and I'm trying to withdraw 5,000, or withdraw means transfer. I'm trying to transfer 5,000 rupees, one through mobile banking and another through net banking. And I'm saying concurrent, but what it says is a database should not allow two users, or one user cannot change a piece of information before another consumes it. So these two transactions cannot concurrently happen on the same field in the database table. That is concurrency. Logically, you also understand it is very important. Otherwise, people will withdraw extra money if you think from banking, but you have to think from all other applications, and this makes sense. Isolation. A given transaction, when we use the word transaction, please understand in all of these, whenever I'm using the word transaction, it means a SQL query. SQL query can be insert, it can be a update, it can be a delete, it can be truncate. Okay. Isolation. A transaction must be isolated from other transaction, which means a transaction sees the data before the operation are performed or after the operation has performed. It can't see the data in between. So here there is a user 1. This person is firing a insert query on a table, say customer table. And here there is another user. As you can understand, insert is basically putting data. And here is another user who is writing a select query. Now, this insert query is going to probably insert thousands of records, and this person is parallelly firing a query to select. What this isolation says that if this select query has to execute, then it should take a snapshot of the data which was before insert, or it should take a snapshot of the data after insert. it should not take a snapshot when the insert was happening. In between, it should not, because in between the data is continuously changing. So a query should be able to see data either before the operation, another transaction operation is completed, or after. Okay, that is what isolation. Durability, whatever data is committed in the database, you shut down the server, there is a power loss, there is a server crash, irrespective of what happens, when you restart, all data should be available. There should be no data loss. And this is called durability. All database provide you these features. ACID properties is available by default in all database. We as users of the database should not be bothered, because by default it is all enabled. Okay. Application of database. There are two main applications. At a high level, we will understand. We are not going to go into detail. One application is online transaction processing, OLTP. You go to bank and you do transactions. You do transactions using net, you do transactions using mobile, you do transaction from ATM, you go to branch and do transactions. Now when you do transactions, you want your, when you do transaction, some information is being inserted, some information in the system might be updated, and sometimes some information might be deleted. You want these insert, update and delete transactions, queries to execute fast. You don't want these transactions should happen slow. The database design for these kind of applications, ticket booking system, banking system, any of these where you do online transaction, the design is a OLTP design. On other hand, within the organization, you want information which is reports. You are looking for reports, MIS, status of your business, which means you are pulling data from the system. And when you want report or you want a MIS, you want the data should be pulled fast. In that case, the design we follow is a OLAP design. So there are two types of applications of database. One is a online transaction processing application, example ticket booking system, and second is reporting systems where we use online analytical processing design. High level terminologies, just make a note of it. As you get more into database world, you will understand these. Okay, but at this point of time, terminologies. How we structure the entire database, the tables in the, that is a complete science methodology, and that methodology is called data modeling. And what is a data model? A collection of tools for describing data, the relationship between the data, the semantics, and the constraints. Now, what do you mean by these things? By data means data. For example, we speak of customer. A customer, for customer, we may say customer, we give a customer ID. The customer will have a name. The customer will have a date of birth, gender, phone number. Technically speaking, for a business, a customer is an entity. Now, what all information you capture for that entity, it is up to you, because that entity, how you want to define your customer, and accordingly you will capture the fields. You may have gender, phone number, and you may say, hey, date of birth is not important for me. Why should I bother the customer? All about semantics. How a data object, a concept, or a real life entity is stored in a tabular format. Please understand, a customer, I can store a customer data in one table, or I can store a customer table in two tables or three tables. Now, two table, how it can come? For example, you define a customer and then you say, okay, hey, for the customer, I would like to have the address, but I want to have his home address, and also I want to have his work address, which means you are defining a customer and you are wanting multiple address information. So you may end up having two tables, one separate table for home, right? So the point is how you represent a concept, a entity in your database design, that is called semantics. Okay, then there will be constraints. Constraint can be, there is a customer and you have taken his one of the identifier information. For example, in India we have PAN card. In foreign countries like US, you have social security number. In India we have PAN, we have Aadhaar. And you may say a constraint, in a given table a PAN card or a Aadhaar number cannot be duplicated, which means you are putting a constraint, the same number cannot come two times in the table. It is a constraint. Okay, so a data model is data, the data itself, the relationship between the various data tables, customer account table, the relation primary key, foreign key. Semantics, we will come across these terminologies. I'm throwing some jargons, primary key, foreign key, but we will come across those as we move forward. Semantics, I explained how you create the table structure, how you want to represent the concept as tables. Constraint, various types of constraints are there. The PAN number should be unique. We put a unique constraint. Date of birth field cannot be empty, which means the customer has to mandatorily give. He cannot leave it optional. So null, not null. Null means you can have null value in it. If you put not null, which means you cannot allow null. All these things are part of data model. The process of creating the data model is called data modeling. And this process is a three-step process. First, you create a conceptual model. You convert your concept into a logical model. Then finally, you create a physical model. Try to understand this at a high level. You think that you want to start a education institute. You go to a database designer and you tell the database designer, hey, look, I want to start a education institute. Now, as an education institute, I will be offering various courses to the students. And these courses will be delivered by highly qualified trainers. Now, at a very high level, if you start putting the business and you start thinking the business to be captured in database system, which means at a conceptual level, you have student, you require some table to capture the student data. You are offering various courses, which means person coming online onto your website, they should be able to see courses, or you should be able to have these details of your courses in the table, something. You will have various trainers, but to be able to assign a trainer for a given course, you need to know the skill set, and you may require data of the trainer, his contact number, email address, so that whenever you have the requirement, you can pull the data and call the person. So you require trainer details. A course, you may say that, okay, given course, I will give the course in January month, then I will give it in June, then I will start another batch in say September. Then a given course, you are offering it as batches. What are you doing? At a high level, you are detailing your concept. This is a very preliminary structure. It is very coarse. It is very high level. It is abstract. There's no detailing. You are just saying, hey, I want a student. And the student data should be captured. What to be captured? You're not saying. I want student data to be captured. I will have courses. What all things you will tell about courses, how many hours course it is, and so forth. You're not detailing. It is abstract. It is sparse. But this is the beginning. This is called a conceptual model. Then you try to put more details into it. For me, a student, I should be giving each student a identifier, a roll number, a unique number by which I should be able to identify the student. And what all details I want to capture: name, gender, date of birth, and so forth. Each course I have, I should be able to have a unique identifier. I should capture name, description, duration, fees, trainer, name, and so forth. Now what you're doing, you're detailing it, and you're trying to connect the dots. For a given course, you will have batch. So you will create for a given course batch. A student is going to enroll into a batch, but you cannot have direct connection like this. So you may have to have some, because there are certain constraints by which, because of which you will not be able to have it. I'll tell you what it is. It is there. You cannot have many to many association. What is many to many? One student can enroll into many batches, and a given batch can have many students. So if you see, the relation between the two tables is a many to many relation. One student can enroll into many batches. A given batch can have many students. This kind of relationship in database we say is a many to many. And when we have a many to many, we have a mapper table in between. That's the reason I did not connect directly this. Eventually, you will learn all of these tricks of database design. Don't worry. And similarly, you will associate a trainer to a batch. Again, you have many to many association between them. So you will again introduce a mapper table. Okay. But the point is, at this point, you have to understand that data modeling is a three-step process. You start with a concept, what design you want. Then you start blowing up. You start detailing the concept. Finally, you will now implement this structure in a database by writing DDL statements, create table, put constraints, relate one table with another. And when you actually put the structure in a database, it becomes a physical data model. I know we have covered lots of theory, and you are very eager to start creating this physical data model, start typing syntaxes. So we get started on MySQL. In our upcoming session, we will start with DDL statements. There are lots and lots for you to learn. In our upcoming session, we'll start with DDL statement, create, drop, alter, what all constraints we can put while creating a table. We'll see all of that. Till then, thank you, bye bye. And once again, if you have not subscribed to our channel and you like the content that we are showing and putting all of this on YouTube, then request you to kindly subscribe to our channel. This will motivate us to put more videos on the YouTube. Thank you, bye bye. See you in the upcoming session.